Hello everyone, my name is Dan the Tutor. This is a clip from one of my weekly group tutoring sessions at the University of Delaware for Math 221. If you have any questions, please leave them in the comments below. Thank you and enjoy. So let's get started with indefinite integrals. Number 1, I just want to know what is the integral of the square root of 2 dx. An easy one to get started. So I've got good news for you. This is a very easy integral. It follows the constant rule, which pretty much says if I have the square root of 2, and it doesn't matter what the number is, like the number could be 2, the number could be 5, the number could be 12, could be negative 1/5. It doesn't matter. Whenever you have an integral like this, I'll just write all of these real quick because all of them take 2 seconds to do. The integral of square root of 2 dx is going to be square root of 2 times x plus c. Final answer. In other words, if you don't see an x in the integral, literally just add an x and you're done. So just to go down this list of 4 right here, integral of 2 dx is 2x plus c. Integral of 5 is 5x plus c. Integral of 12 is, you guessed it, 12x plus c. And then the last one, integral of negative 1/5 would be negative 1/5 x plus c. I'll give you like 10 seconds to write this down, but it's very easy whenever you just have a number and an integral. It's literally you just add x. Hopefully some of you remembered that. Okay, we're going to move on to number 2 now. Number 2, we're going to ramp up the difficulty substantially. We have the integral of 7x to the 4th plus x to the 1/2 minus 2/3 x to the 3/4 power end parenthesis dx. This just looks terrible. I know. I apologize. But here's what I'm going to tell you. It follows the power rule for antiderivatives. What does that mean? So just a quick recap. If we were talking about derivatives and I had like x to the 4th, well, the derivative of x to the 4th, you pull the 4 out in front, right? And then we say minus 1 power, so it would become 4x cubed. We're going to do the opposite of this for the power rule for antiderivatives. Instead of saying minus 1, I'm going to say plus 1. So look at this first one here, 7x to the 4th. Another thing worth mentioning, just real quick, whenever you have an integral like this with like the plus signs and the minus signs separating thing, this is not a U substitution because everything is just plus or minus. This is actually a pretty straightforward example despite how crazy it looks. What I'm trying to say here is I can break this up into 3 separate integrals. It's the integral of 7x to the 4th dx plus the integral of x to the 1/2 dx minus 2/3, I'm sorry, I missed the integral, minus integral of 2/3 x to the 3/4 dx. We can split it up into 3 different integrals. This is obviously helpful because now it's very straightforward what each integral is. It's going to be 3 power rules for antiderivatives, and here's how we do it. So first, 7x to the 4th power, I'm going to rewrite that as 7 integral x to the 4th dx. The reason I did that is because the 7 is a coefficient, which means I can just write it out in front. And the integral of x to the 4th, this is where the power rule kicks in. Integral of x to the 4th is going to be x to the 4 plus 1 power, so 5, divided by that power, 5. This is the integral, 7x to the 5th over 5. We're about to do a bunch of these today, so get used to the power rule if you don't remember it. Okay, that's it for the first one. Now the second one, integral of x to the 1/2 dx. Once again, I need to add 1. This is not fun because a lot of you suck at fractions for some reason. I blame your middle school teachers, but that's besides the point. X to the 1/2 plus 1 power. Well, 1/2 plus 1 is the same thing as 1/2 plus 2/2. Get a common denominator. That's a horrible 2. Okay, 1/2 plus 2/2. That would be then x to the 3/2 power. 1/2 plus 1 is 3/2. X to the 3/2 divided by 3/2. We'll simplify that in the next step. But that's it for the middle term. I'm going to clear some space here. And now we need to focus on the last one. Minus 2/3 x to the 3/4. Again, this 2/3 is a coefficient. I can write that out in front like this. Times x to the 3/4. Need to add 1 to that. What is 3/4 plus 1? So instead of plus 1, I'm going to write plus 4/4, get the common denominator again because that's helpful. That's going to be 7/4, which means this integral is x to the 7/4 power divided by 7/4. Again, I'm going to simplify that in the next step. And now that we finished all three integrals, now I'm going to put plus c, because you cannot forget the plus c after your integral. Hopefully all of this is starting to ring a bell. Okay, so this is a good second to last thing I'm going to write. The last thing I'm going to write is, well, the more simplified version of this. And that is, I don't like complex fractions. I'm going to change it all the time. What is a complex fraction? It's this 3/2 in the denominator and this 7/4 in the denominator. Everything else is pretty much fine. So I'm going to rewrite this as, the first term stays the same. I'll even write it as 7/5 x to the 5th power. That's fine. Plus, here's where it gets annoying. X to the 3/2 divided by 3/2. The way we deal with complex fractions is I take the reciprocal of my denominator. What is the reciprocal of 3/2? It's 2/3. So 2/3 times x to the 3/2. That's how I rewrite it. Now it's a normal fraction. Before it was a fraction in the denominator. The way we changed it, again, we took the reciprocal. Any questions so far? Don't be afraid to ask. So now, minus 2/3, because that's the third term now. And the 7/4 into the denominator, I'm going to rewrite as, I'm going to flip it. So now it's 4/7 as a normal fraction times x to the 7/4 plus c. You could even combine the 2/3 and the 4/7 if you wanted to. I'll just leave it like this. This is fine. And this is going to be our final answer for this one. Again, the biggest part about this one is just knowing how to do the power rule for antiderivatives. Obviously, it's going to take a lot of practice. We're going to be looking at a lot more of these types of questions today. So stay tuned. And honestly, I'm done with my indefinite integral questions. That's it for indefinite integrals. Obviously, you have more practice to do on your own. But I want to move on to U substitution because... Don't forget to like and subscribe. If you want me to start doing free weekly group sessions at your university, please post in the comments below or email me at dan@danthetutor.com. Thanks, everyone. Bye-bye.